Hi dear students, this class I am going to discuss about binomial theorem for any index. Till now we discussed binomial theorem for positive integer. Now we are going to discuss binomial theorem for any index. So this is the expansion of 1 plus x whole to the power of n. N is a negative integer or n is a rational number that can be expanded as 1 plus nx plus n into n minus 1 divided by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x cube plus and so on. This summation will go up to infinite terms. This summation will go up to infinite terms. This expansion is valid only when mod x less than 1. So that is the expansion of 1 plus x whole to the power of n. But what is the general term in this expansion? That means I am asking what is r plus 1th term in this expansion. Observe, this is the first term. Second term is n into n minus. Second term is n into n minus 2 plus 1 divided by 2 factorial into x square, that is the third term, right? So first term, this is second term, and this is the third term, right? Next, fourth term is, observe here, n into n minus 1 into n minus 3 plus 1 divided by 3 factorial into x to the power of 3. This is third term, right? And this is fourth term. Fourth term is nothing but t4. T4 is nothing but t3 plus 1. Third term is nothing but t3. T3 is nothing but t2 plus 1. t2 plus 1 is equals to n into n minus r plus 1 by r factorial. n into n minus 1 into n minus 2 by 3 factorial, right? Now from this generalization, can you say what is r plus 1th term? R plus 1th term is equals to n into the general term in the expansion of 1 plus x whole to the power of n, when n is a rational number or a negative integer, is given by n into n minus 1 into n minus 2 into and so on, n minus r plus 1 divided by r factorial into x to the power of r. So this is the general term in the expansion of 1 plus x whole to the power of n. n into n minus 1 into n minus 2 into and so on, n minus r plus 1 by r factorial into x to the power of r. That is the general term in the expansion of 1 plus x whole to the power of n. This expansion is valid only when mod x less than 1. Now what I am going to do here is, x is replaced with minus x and n is replaced with minus n. Then what happens? This can be written as 1 plus nx. Next, in place of n we are writing minus n. In place of n we are writing minus n, and in place of x we are writing minus x. Then what happens? This one, n into n plus 1 divided by 2 factorial into x square. Next also here, n into n plus 1 into n plus 2 divided by 3 factorial into x to the power of 3 plus and so on, right? So that is the expansion of 1 minus x whole to the power of minus n. Observe here, this can be written as 1 plus, so nx, this can be written as n plus 1 c2 into x square. The next one we can write it as n plus 2 c3 into x cube plus and so on, right? Again observe here, this can be written as n plus 2 minus 1 c2 into x square. The next one we can write it as n plus 3 minus 1 c3 into x cube plus and so on. X cube coefficient is n plus 3 minus 1 C3. X square coefficient is n plus 2 minus 1 C2. Now tell me, in the expansion of 1 minus x whole to the power of minus n, can you tell me what is the coefficient of x to the power of r? In this expansion, what is the coefficient of x to the power of r? X cube coefficient n plus 3 minus 1 C3, n plus 2 minus 1 C2. In this expansion, the coefficient of x to the power of r is given by n plus r minus 1 CR. Right? n plus r minus 1 CR. That is the coefficient of x to the power of r in this expansion. The same we can also write it as n plus r minus 1 C n minus 1 also. The reason is NCR can be written as NC n minus r also. With the help of that we can write in this way. Now this is the coefficient of x to the power of r in the expansion of 1 minus x whole to the power of minus n, right? Now can you say what is the coefficient of x to the power of, what is the coefficient of x to the power of n? X power n coefficient in the expansion of 1 minus x whole to the power of minus r. Same way, come on, try to say n plus r minus 1 C r. Observe here, r plus n minus 1 C n minus 1, r plus n minus 1 C n minus 1. That's why in this the coefficient of x to the power of n in this expansion is given by n plus r minus 1 C r minus 1, right? So otherwise, suppose you want to find out the coefficient of x cube in the expansion of 1 minus x whole to the power of minus 2. Come on, tell me what happens. 3 plus 2 minus 1 C 2 minus 1. The coefficient of x cube in this expansion is given by n plus r minus 1 C r minus 1. Better to know. This will be useful in the permutations and combination chapter also. Very important result. So this particular idea we have to know. The coefficient of x to the power of n in the expansion of 1 minus x whole to the power of minus r is n plus r minus 1 C r minus 1. Right. So based on this information, just I'll try to discuss a few problems. As you know, the expansion of 1 plus x whole to the power of n, as we discussed, 1 plus nx plus n into n minus 1 divided by 2 factorial into x square plus and so on. Now can you tell me what is the expansion of 1 plus x whole to the power of minus 1? 1 plus x whole to the power of minus 1 is equals to 1 minus x plus x square minus x cube plus and so on. This expansion is valid only when mod x less than 1. Now tell me what is the expansion of 1 minus x whole to the power of minus 1. Nothing here. In place of n I am asking you to substitute minus 1. Wherever n is there, in place of n write down minus 1, you will get the same. Now 1 minus x whole to the power of minus 1 is equals to, now x is replaced with minus x. 1 plus x square plus x cube plus and so on. And what is the expansion of 1 plus x whole to the power of minus 2? Nothing difficulty. Wherever n is there, in place of n in this formula we have to substitute minus 2. Then we get 1 minus 2x plus 3x square minus 4x cube plus and so on. Right? Can you tell me what is the expansion of 1 minus x whole to the power of minus 2? That is equals to 1 plus 2x plus 3x square plus 4x cube plus and so on. That is the expansion of 1 minus x whole to the power of minus 2. These are better to know as a standard results. let's do few questions, thus I can say few applications based on this information. So this is the first question. The first question is saying that 1 minus 4x square whole to the power of minus 9 by 4. This expansion is valid for what values of x? This expansion is valid for what values of x? As we discussed, modulus of 4x square must be less than or equals to, modulus mod x less than 1. That means modulus of 4x square less than 1. Then we can write mod x less than 1 by 2. Mod x less than 1 by 2 means x values lies between minus 1 by 2 and plus 1 by 2 or not. X values lies between minus 1 by 2 and plus 1 by 2. That is the range of x. For these values of x only, that expansion is valid. Let's another question here. 1 plus x whole to the power of 27 by 5. What is the first negative term in this expansion? First negative term we have to find out in this expansion. What happens? What is the general term? Tell me. Tr plus 1 is equals to n into, right, n minus 1 into n minus 2. X is positive given, right? If x is positive, the first negative term in this expansion, n into n minus 1 into n minus 2 into n minus 3 into n minus 4. We are not getting negative. 5 4s are 20. 27 minus 20 positive only. Next, n minus 5, right? The next one we are getting n minus 6, because 5 5 is 25. In that case also no problem. So this we can write it as n minus r plus 1 divided by r factorial into x to the power of r. Come on, tell me this is, because when r is equal to 7, you will get this total value 6. R is equal to 7 means we are getting the negative value. Here up to here no negative, no negative, no negative, no negative. So r is equals to 7. Whenever r is equal to 7, we are getting the negative term. This value becomes negative or not? But this value is negative means the total value is negative. That's why when r is equal to 7, we are getting the first negative term. So I can say r is equal to 7 means 8th term is the first negative term in this expansion. So there is another question he is asking, coefficient of x to the power of 7. X power 7 coefficient we have to find out in the expansion of 1 minus 2x plus 3x square and so on, minus and so on, whole to the power of minus 4. In this expansion we have to find out the coefficient of x to the power of 7. Right. First of all, this can be written as 1 minus x, 1 plus x whole to the power of minus 2. Because 1 minus 2x plus 3x square minus and so on, that is the expansion of 1 plus x whole power minus 2 whole to the power of minus 4. That we can write it as 1 plus x whole to the power of 8. So the coefficient of x to the power of 7 is 8c7 into x to the power of 7. So x power 7 coefficient is 8c7, that is nothing but 8c1. So we are getting 8 as an answer. Next, another question is asking the coefficient of x to the power of 5 in the expansion of 1 plus 2x plus 3x square plus and so on whole to the power of minus 3 by 2. In this expansion we have to find out the coefficient of x to the power of 5. Yes, we can write this one as 1 minus x whole to the power of minus 2 whole to the power of minus 3 by 2. That's what we are getting, 1 minus x whole cube. In this expansion, the highest power of x is 3 only. X cube is the maximum power of x. That's why there is no chance of getting x power 5 term. That's why the coefficient of x to the power of 5 is equal to 0. So this is the another question he is asking. Coefficient of x to the power of 5 we have to find out in the expansion of in this 1 plus x whole power 21 plus 1 plus x whole to the power of 22 plus and so on plus 1 plus x whole to the power of 30. Right? So two ways we can do this particular question. The one of the method I am discussing, all of you pay attention here. We have to find out the coefficient of x to the power of 5 in this expansion from 21 to 30. Total how many terms they are? 10 terms. Now these 10 terms are in geometric progression with a common ratio as 1 plus x is the common ratio. Sum of 10 terms of a GP a into r to the power of n, that means 1 plus x whole to the power of n. Total these are 10 terms. 1 plus x whole to the power of 10 r to the power of n minus 1 by r minus 1. We have to find out the coefficient of x to the power of 5 in this expansion. That means we have to find out the coefficient of x to the power of 5 here. That means 1 plus x whole to the power of 31 minus 1 plus x whole to the power of 21 divided by x. Here we have to find out the coefficient of x to the power of 5. Right? That means we have to find out the coefficient of x to the power of 6 in 1 plus x whole to the power of 31 minus 1 plus x whole to the power of 21. Are x power 6 by x? You will get x power 5 or not? Now tell me what is x power 6 coefficient? 31 C6 minus x power 6 coefficient 21 C6. So 31 C6 minus 21 C6 is the answer. So observe here. Here x power 5 coefficient is 21 C5. Here x power 5 coefficient is 22 C5. Next and so on. Finally 30 C5. Just by using the Pascal's identity. Sir, what is the Pascal's identity? NCR plus NCR minus 1 can be written as n plus 1 CR. Right? So that's why 21 C5 plus 22 C5 plus and so on plus 30 C5. So what we can do here? Now add 21 C6, subtract 21 C6. Now this can be written as 22 C6. Again this can be written as 23 C6. Yes or no? And so on, continue up to the last one. You will get add 1 here. 31 C6 minus 21 C6. The same answer we will get. So that is another way of doing the same question. Okay. So this is the another one. He is asking y is equals to 2x plus 3x square plus 4x cube plus and so on. Then he is asking x value in terms of y he is asking. He has given y in terms of x. In this question he is asking to find x in terms of y. We have to find out x in terms of y. So what to do? So 1 plus y is equals to 1 plus 2x plus 3x square plus 4x cube plus and so on. Both sides 1 added. Yes or no? Now 1 plus y is equals to, what happens this one? 1 minus x whole to the power of minus 2. 1 plus y is equals to 1 minus x whole to the power of minus 2 expansion. Now this can be written as 1 plus y is equals to 1 by 1 minus x whole to the power of minus 2 expansion. So this is, you got 1 plus y in terms of x. Now from this you can find out x in terms of y also. Okay. So that is the way of doing this particular question. So let's have a discussion of another question here. Now the question is given like this. S is equals to 1 by 5 plus 1 into 3 divided by 5 into 10 plus 1 into 3 into 5 divided by 5 into 10 into 15 plus and so on. He is asking what about its value. So as you know, the expansion of 1 plus x whole to the power of n is equals to 1 plus nx plus n into n minus 1 divided by 2 factorial into x square plus and so on. So now compare this one with this. Okay. So what is missing? 1 plus s is equals to 1 plus 1 by 5 plus 1 into 3 divided by 5 into 10 plus 1 into 3 into 5 divided by 5 into 10 into 15 plus and so on. Now on comparison you will get nx is equals to 1 by 5. Next one, nx into nx minus x divided by 2 factorial is equals to 1 into 3 divided by 5 into 10. Because the first term is 1, there also 1. Here 1 by 5 is comparing with nx. Next second term we are comparing with this. Now in place of nx what we can write? 1 by 5. So we will get 1 by 5 into 1 by 5 minus x divided by 2 factorial into 1 into 3 divided by 5 into 10. Now this further simplification we can write 1 minus x is equals to 3, right? So 5 and here 5 into 10 cancel, 1 minus 5x is equals to 3. Therefore we are getting 5x is equals to minus 2, x value is equal to minus 2 by 5. But when x is equal to minus 2 by 5, if you put x is equal to minus 2 by 5, n into minus 2 by 5 is equals to 1 by 5. Therefore we are getting n is equal to minus 1 by 2. And this total is equal to 1 plus x whole to the power of n. We compared this one with this. We are comparing this with this. That's why I can write now 1 plus s is equals to 1 plus x whole to the power of n. We got n value is equal to minus 1 by 2. Now this further simplification, 3 by 5 whole to the power of minus 1 by 2, that is nothing but square root of 5 by 3 is 1 plus s value. From this we can find out the value of s is equal to root of 5 by 3 minus 1. So this difference, this total sum s value is equal to root of 5 by 3 minus 1. So another question of the same type I am giving. Try to work out this particular question. This is the question given. S is equals to 5 divided by 9 into 18 plus 5 into 8 divided by 9 into 8 into 27 plus 5 into 8 into 11 divided by 9 into 8 into 27 plus and so on. 2 terms, but here 3 terms. 3, 9 into 8 into 27 into 36. So 1, but here 2. So that's why we are balancing. Okay. So this can be written as s is equals to 2 into 5 divided by 9 into 18 plus 2 into 5 into 8 divided by 9 into 8 in 9 into 18 into 27 plus 2 into 5 into 8 into 11 divided by 9 into 18 into 27 into 36 plus and so on. So why you are multiplying with the 2? Here you can see 11 minus 8 is equal to 3, 8 minus 5 is equal to 3, 5 minus 2 is equal to 3. That's why both sides we are multiplying with the 2. Both sides we are multiplying with the 2. Next what I am doing is 2s is equals to 2 by 9 plus 2 into 5 divided by 9 into 18 plus 2 into 5 into 8 divided by 9 into 18 into 27 plus and so on. Here also we have to add 2 by 9. Now add both sides 1. So both sides we have to add 1. Now this you can compare with 1 plus nx plus and n into n minus 1 divided by 2 factorial into x square plus and so on. Now compare these two, you will get x value and you will get n value also. That's why I can write 11 by 9 plus 2s is equals to 1 plus x whole to the power of n. From this we can find out the value of yes. Okay, so that is the discussion regarding binomial theorem for any index. Okay, bye.